I'm going to do a few examples of how lighting works in kind of a basic level. So I'm going to make some 3D primitives and we'll talk about how lighting works in that context. And then in part 2, I'm going to discuss the impact of creating light maps and other elements of assets. So in Unity, and this is similar in most game engines, but in Unity, there's a certain amount of pre-baking that goes into creating lighting. Most lighting by default is dynamic, but you actually have to set up assets so that they can pre-bake lighting properties in order to get a more elaborate context for those assets. So basically what we're going to do, let's go ahead and I'm going to create a plane. So I'm going to go to Game Object, 3D Object, Plane. And then I'm going to go to Game Object, 3D Object, and select Cube. So now that I've got a cube here in the environment, it's just kind of a really basic setup. I want to talk about how baking lighting works. So we've got a directional light, and that's totally cool. It's currently set to baking real time. It has soft shadows, and there's a number of other properties that relate to that. But for right now, the first thing that we want to do in order to be able to create some pre-baked lighting effects is we need to mark the objects in the environment to static. So there's this checkbox called static at the top here. And if I mark these both to static, and then I make sure I save my scene, then what this does is it kind of pre-bakes details of lighting into the environment. So the main impact that has is it creates a little bit of like a light bounce effect by default. So let's try to do something so that we can more clearly illustrate that. So I'm going to create a couple more objects. So first of all, we've got this lighting tab, and if you don't have it, you can go to Window, Lighting, and the lighting tab we can break off, or we can dock somewhere else, and I'm gonna just dock it here for right now. But lighting has a bunch of different settings that we can control. So one, for example, is setting up a skybox. You don't actually have to set the sun, but if you want it to pick a sun for the procedural skybox, you can do that by slotting it in there. There's Ambient Gi settings here, and then there's settings that apply generally, which is like the general GI settings. Then there's baked GI and pre-computed real-time GI. Actually, I'm going to slot this over here because I think it's a little bit easier to read that way. And there's also things like fog, which you can turn on, which is usually kind of cool. But so what happens is in Unity uses a system called Enlighten, which is a way of propagating global illumination, which is basically indirect light bounces that occur in a scene. When light hits a surface, it will bounce off that surface. It will also create a bounce lighting effect. So I'm going to go ahead and create an area that has a little bit more concave surfaces, or a little bit more surfaces to basically traverse, for the light to traverse. So I'm going to kind of like make some extended walls with these cubes. So I'm going to make the scale 10 because I know that'll be the exact same size as this wall here. I'm going to line it up with the floor there. Hit Control D, and then I'm going to hold down Control so I can make a copy. It's snapped. Then I'm going to select both of these, hit Control D. I apologize, I'm actually a little bit sick right now, so apologize if my voice sounds a little bit hoarse. So then I'm also going to actually make this kind of an enclosed space. So I'm going to grab one of these here on this one side, and I'm going to actually rotate it a bit so that it makes kind of like a cover on the environment. And yeah, so that'll be okay. And so then what I want to do is I want to make sure that all of these cubes are marked static. And then you'll notice, because it's set to lighting auto bake, this will actually immediately start updating the scene. And so what happens when you're done baking that is that you get kind of this dramatic light bounce effect, where it looks like suddenly the environment has a lot more character than it did before. And so if I rotate the light around, you'll notice how the indirect lighting gets affected by that. So you'll see there's kind of a shading that happens here. And so if I go to the inspector and just start like rotating the light around, it's kind of a subtle effect, but you can see how, like, so for example, when the light is here, it's actually bouncing light onto the walls. And all of this is actually real time. The actual light interaction, fully real time, and it can work in pretty much any scenario. The difference is that the objects that create these kind of light bounces have to be static, so they can't move, and essentially you have to create a pre-bake in order to make this work. So let's modify a few properties here, and then we'll be able to see how this affects things. So for example, under the lighting tab, pre-computed real-time GI is what controls this effect. So under the real-time resolution, we have 2 texels per world unit. So the first thing I want to show you is what happens if we change this to be much lower. So if I change it to 0.1, basically it becomes a less accurate solution, and it's a little bit more generalized. So you'll notice that you won't actually see all of the kind of the shadow effects and things, because it's basically using a lower resolution to calculate that, and that can make it a little bit better for performance, but it does reduce the visual quality. It also takes a lot less time to bake. But then we could go in the opposite direction, and we could say, okay, we're going to make a resolution of 4 instead of 2. And I will say that in most video game environments, the resolution becomes a little bit untenable when you get past 2. I think 2 in most actual real-time game environments is probably the highest you're going to want to go, because past that you start seeing some real performance overhead. But you can see how this affects the quality of the lighting that you get. So obviously, now that we've got this at 4, we've got a lot more vivid shading. So like you can see there's a shadow here on the ground and all that kind of stuff. So let me actually up this again to 8. And then I'll go ahead and let it rebake. And then we'll just have an idea of what that does. Now, the higher resolution you place this at, the more the environment will actually take to bake. So you have to be a little bit careful with that. So like, for example, 8 is probably way beyond a resolution that would ever be feasible for making a full game environment. Like, you can do it with a scene like this because it's reasonably small, but once you start having anything of any particular size, it'll become a lot more difficult. Now, one thing that's kind of interesting about how Unity baking works is that everything that you bake is stored in what's called the GI cache, which is a way of recalling bake data more quickly to increase the time, or to reduce the time that a bake takes in subsequent tries. So actually, if you start by doing a lower resolution preview bake, it will bake substantially faster, and then that data can be used to make higher resolution bakes faster. Whereas if you do, say for example, if I jump down to a 4 resolution, it'll rebake that in a few seconds. And then if I wanted to make it an 8 resolution again, I could go back, and that could be done in only a few seconds, whereas it might take 30 or 40 seconds with this scene just from a standstill. So I'm actually going to switch back to 4 because I personally actually think the visual quality is a little more consistent at 4. When you get up to 8, it starts having pretty high resolution artifacts that start popping in. But okay, so I want to talk a little bit about some of the features of this lighting and why you might want to use it, and then I'll show you how the baked lighting works, and then we'll talk about some more enhanced features. So one thing that you can do is once lighting is baked, you can actually apply material properties that have an impact on the lighting environment to no additional cost. So for example, I'm going to go ahead and make a new folder called Materials. And I'm going to make 3 materials. I'm going to call, right-click, select Create Material. I'm going to make one called M_red. Create a new material. M_green. Create a new material. M_glow. And then, so basically what I'm going to do is under the red one, I'm just going to change it to a red color. Green. Just change the albedo color to green. And then for the glow, I'm going to make it kind of a yellowy color. And then under the emission, I want to change that to kind of a yellow emission color. And then I'm going to make it a little bit more intense, increase the brightness in the settings here. So, so what I can do is, so for example, if I take this green and apply it to this wall, and then take the red and apply it to this wall, then you'll notice how automatically this environment starts getting influence from these lights, or from the impact of the light hitting the colored surface. So you can see that when the light is really hitting this area here, it creates this red glow, and when it's hitting this area here, it has this strong green glow. And that's pretty neat. But even more broadly than that, I'm going to actually go ahead and take out the directional light for a second, so that the environment is kind of dark. And then I'm going to add the glow material to the box in the middle. And what you'll notice is that the box in the middle is now actually emitting light in addition to having a glowing surface on it. So if I increase the intensity of the glow, it actually affects the lighting of the entire environment, and it does that in real time, which is pretty cool just as an effect. And I think hopefully you can see how that might be incredibly useful for creating advanced lighting. And then the other thing that's worth noting about this is that the performance of this is much less expensive than using conventional lights. Now I want to make a couple of quick points about how this system works. I'm actually going to go ahead and undo that so that we don't have the glowing box there. But so the other thing that's worth noting, so I'm going to turn off my directional light. Actually, I'll leave it turned off. Is that if I place a dynamic object, so if I go and I make like a sphere here, and I just kind of like stick this somewhere here, you'll notice that it actually doesn't look very consistent with the lighting around it. And basically that's because it's it's a dynamic object. It's not set to static. And now the first thing that you might think is like, well, we might want to just set it to static so that it'll have the matching lighting. So if I set this to static right here, it'll rebake really quickly. And then when it's all done getting rebaked, then that object will now have the proper lighting contributions. It just takes a second and then it should be done. Now, anytime you bring a new object into a scene, it takes longer to bake. But okay, so then now this looks like it's a little bit more consistent with the environment here, but there's a big problem, which is in some cases we actually need something to not be static and still be in the environment. And obviously, we don't want to have to make every object static in order for it to look consistent with the game world. So what I'm going to do is I'm going to turn off static here, and I'm going to set up what are called light probes, which are basically a technique to light static or dynamic objects with the lighting contributions of the static scene without having to actually bake the lighting that way. So, oh, actually that was wrong. I made the wrong thing dynamic. Okay, so there we go. Okay, so what we'll do is, like, let's say we add a rigid body to this this sphere, and I'm gonna move the camera in here. So I'm gonna go to main camera, and I'm going to go to game object, align with view. So then if I play the scene, we'll notice how that the rigid body causes that ball to fall. And in fact, I'll move it over here a little bit so we can see it better. And so we can tell that obviously that means it's a dynamic object. So we can't make that static. So let's go ahead and go to object, game object, light. And what we're going to do is we're going to create what's called a light probe group. And what's cool is actually the moment I drop this in, you'll notice that the lighting on that object massively improves. And that's because it's now being influenced by the placement of these light probes. So what's cool is that you can, like, set up a light probe group. Like, so for example, here I'm kind of scaling this out so that it can roughly match the shape of the room. And then I'm going to actually scale it on the y-axis as well. And then you can add in more probes. So there's a couple of ways of doing that. One is to just, like, add probe. So for example, if I just add a probe here, then I could, like, maybe add a probe in front of the box. I could go to add a probe, and it'll actually snap those probes to wherever it is that I'm looking. So if I center my view, I can get more probes added into this group just by kind of, like, looking where I want them to go. And so, like, for example, if I wanted one on the middle of this wall, I could just go to add probe, and then I got to be careful that it doesn't think I want it somewhere else. But then I can, like, position them there. And the more probes you have, the more accurate excuse me, the more accurate the lighting contribution will be. So then, for example, if I turn my directional light back on, then you'll notice that if I start moving this dynamic object around, it shows that it's getting influences from different sets of reflection probes based on which ones are basically the closest or most accurate contributions. So if it's all the way over here, it's going to be receiving influence from those probes, and if it's over here, it's going to be receiving influence from those probes. And the main idea is that this is not 100% accurate. with what you would get out of baked lighting, but it's probably the closest you can get in most cases without doing like a really elaborate setup, which would be basically limiting your options as far as utilizing these objects. So basically it gives you an environment object cohesion, which is really what you're shooting for. And light probes are really, really useful. We put them into every scene that we're doing in reflections and graves so that it has the maximum impact. But there's also something else that we can do to make these scenes look more accurate. So, for example, maybe on my sphere, I actually want to make a reflective material. So I'm going to go ahead and create a new material, and I'm going to call this M reflective. And I'm going to stick that on the sphere. And then I'm going to make it like extra smooth, and I'm going to make it kind of metallic-y. And actually what I'm going to do is I'm going to make it look like it's kind of got like a gold texture to it. So you'll notice that it looks like it's reflecting the sky, but it doesn't really seem to be reflecting anything else that's accurate to the environment. And that's because we don't have a reflection probe. So similar to light probes, reflection probes are a way of getting information from the scene, from the static scene, and applying it to all objects, including static and dynamic objects. So I'm going to go to Game Object, Light, and Reflection Probe. Now, reflection probes have to be baked, but you'll notice that they have a really awesome effect, which is that they actually make it look like it's reflecting the entire environment. And all I did was actually just drop it in, and it already looked like it was kind of working. But there's a couple of cool things we can do with reflection probes. So for example, we can change the resolution of a reflection probe. So I can set it to 256. And this reflection probe is set to baked, but you can also set it to custom or real time. And because we've got the lighting set to bake automatically, we can just make changes and we'll see the updates pretty immediately. But the main thing that I want to draw attention to is this option for box projection. Now, in general, reflection probes affect every object that are within their box, but it's treated as kind of an infinitely far away reflection, so it has no physical space. So like moving this object over to this side has no material effect on the reflection versus it being all the way over here on this side. You'll see that it basically looks like the same reflection. But if I go to my reflection probe and I turn on box projection, what it basically does is it projects the reflection onto the edges of this box. So if I want it to be really, really accurate, I can match up the walls with the edges of the box. So, for example, if I click on this button here for editing the bounds, the box bounds of a reflection probe, then I can basically grab the handles here and I can slide them until basically they're just on the outside of the floor and walls, the floor, ceiling, and walls. So, and you can see that if they are through the wall, you'll actually see the inside of the box projection. And then the last one is down here. Oops. So I'm going to slide that up. Let's see. There we go. All right. And I basically just want them to be right on the other side of the wall. And then so you'll notice that like when this this kind of reflective gold object is right next to the red wall, it actually looks like it's right next to the wall. And so similarly, if I slide it all the way over to the other side, it looks like it's actually right next to that wall. And to better illustrate this, I'm actually going to make the floor more reflective as well so that you can see how it uses that box projection. So I'm going to create a new material, M floor. I'm going to drag that onto the floor. Then I'm going to set the smoothness to 1. And I'm actually going to set the metallic to 1 as well. And so what you'll see on this floor is you actually see like a near perfect reflection of the environment. And obviously as I reduce the smoothness, it becomes a little bit less defined. So like, for example, I think maybe that might be a slightly more accurate representation of what a reflection would look like in real life. But what's cool is that then if I switch the different types of reflection probe setting between box projected and non-box projected, you can see what that looks like. So if I turn off box projection, you'll notice that it now doesn't have any specific details relating to where that projection is placed. It's just kind of like out there infinitely far away. But then I turn on box projection, and then it basically snaps to the boundaries of the box. So there's some good and some bad things about this. The main thing that's bad about it is that you run some risks when you're working with a box projection of making a reflection that just doesn't look terribly effective because of a room or an environment that isn't particularly box shaped. Now, I personally think that box projection works in a majority of the time, in the majority of cases, but there are some times where box projection is less than optimal. And you'll just have to get some experience with it to see which times you think that maybe you would want to use box projection and which times you wouldn't. But in general, I really like box projection, and I use it almost all the time because I think it actually creates a more accurate representation of an environment, and it just looks really, really cool. So, one last thing that I wanted to say about this is that different lighting types all can be influencing your baked lighting. So, for example, if I go to Game Object Light, I can create a point light, and this point light will also do light bounces. I can do a spotlight, and this spotlight will also have an impact on both the direct and indirect lighting. And every light that you create has properties that influence this result. So number one, you have, like, most lights have a range. They have an intensity. So in addition to those kind of basic features, obviously you've got things like color, and you can change the color of a light. And you can see how actually the red light is being reflected, bounced into the ceiling. And actually, let me go ahead and reduce the reflectiveness of this floor. So I'm going to make it less metallic, and I'm going to make it less smooth. So you can see how having a bright red light here is actually causing light bounces all around the environment. So if I turn off my directional light, you can get a better idea of what that looks like. But in general, those properties are pretty straightforward, and you can add things like you can turn on shadows. So if I turn on, for example, hard shadows or soft shadows, you can see how then this will cast shadows, but it still has a contribution to the light bounces. So obviously you can see how that affects things. And but what's really cool is there's also a setting for bounce intensity. Every light has a setting for bounce intensity, and this is kind of like a custom tweaking option. But like, so for example, if I wanted it to bounce at a greater value than what the default setting is, I could pump up this light bounce intensity, and I could make it that the light bounces to a really extreme amount. And so some examples of when you might want to do that would be in situations where, say, you have a lot of light bouncing into an environment like an interior space, and you're trying to light that space fairly effectively. So like, for example, here, if I turn on my directional light and I want the directional light to be having more of an impact, I can increase the bounce intensity, and then it'll actually be brighter in the areas where the light is bouncing around. So hopefully that makes sense. But let's go ahead and talk about a few additional properties here. So for one, under the lighting tab, we have the ability to increase or decrease the influence of various features. In the Environment tab, you can change the contribution of the ambient source. So for example, this is used in the skybox, but you also could change it to a gradient or a color, and those are just kind of simplified versions. I pretty much always use skybox, and then you can plug in different skyboxes to get better results. But you can also adjust the ambient intensity. So for example, if I wanted the ambient lighting from the skybox to be more intense, I could multiply the general ambient intensity to be beyond what the default is. Or like if I were making like a horror game and I want it to be really dark and brooding, I could actually reduce the contribution of the ambient. So for example, if I do it like at 0.25 here, and then give it a second for the reflection probe to rebake, then you'll notice that the environment inside here is much, much, much darker than it would have been if the full ambient intensity had been used. And that's a good way of kind of like getting more custom effects. You can also do things like you can affect the reflection intensity. So if, for example, we went back to our floor and made it like ultra reflective here, we could then modulate the reflection intensity and also we could increase reflection bounces, which allows us to pre-bake more information about reflection bounces. And then once it rebakes those reflections, then we'll see those impacts take place. But so I want to, for a second, talk about the alternate version of baking lighting, which is baked instead of pre-computed real-time GI. So fully baked is a non-dynamic lighting. Now, the main difference between the two is that a non-dynamic lighting environment cannot change, but it has the benefit of basically having next to no overhead for lighting contributions. So if we were to say let's go ahead and turn on our directional light here. I'm going to make the floor kind of back to normal. And then I'm going to go and probably increase the ambient intensity, but I'll reduce the bounce intensity of the directional light to get kind of a look like I kind of expect. I'll go ahead and actually, I'm going to turn off pre-computed real-time. So we're only going to be dealing with baked GI. And there's a lot of different settings here, and I think that some of these might be best for you to just experiment with. But what's cool is all you have to do to take advantage of that is start switching your lights from real-time to baked. And then, basically, when it goes through this process of baking the light, you will have an environment that has fully calculated light maps rather than using actual dynamic light. And this is useful in a lot of video game scenarios because games have a hard time often rendering lighting in real time. And if you don't actually need to move your lights, it's better to bake the light down than it is to leave it on dynamic. So you'll see, for example, here the lighting looks almost identical, except that if you look closely, you'll notice that the shadows are a little bit more pixelated now. And so so that we can talk about this, let's actually switch the lighting off of auto for a second. So it's not going to update when we change it. And so I'll show you then if I start rotating this this light around, it actually doesn't make a difference. And in fact, the light being totally turned off will not matter because the lighting is now baked into the scene. So that gives us the ability to make the most performance optimized scenes possible, with the only downside being that the light can't change very drastically. Oh, excuse me. And you'll also notice, like, so if I turn on emissive materials or something like that, I would have to rebake it for this kind of thing to apply. Now, this may seem like it's less featured, which to some degree that it is, but it has a lot of advantages as far as performance. Like, it is way, way more efficient to do lighting in this fashion. So do it if you can, basically, because it would definitely be worth it. And then the only thing that you want to watch out for is you want to make sure that you have an appropriate resolution so that it creates a set of light maps that is not too large, but still has a good balance on detail and influence. So, and then you can also do things like you can add some additional features. So, for example, there's Ambient Occlusion. I'm gonna set Ambient Occlusion at 1, and then I'm gonna turn on Final Gather. And then I'm going to rebuild that. So in this case, I actually forgot I had turned off the directional light, but what you can, this probably illustrates pretty well. You can see that with the Ambient Occlusion turned on, it creates kind of like a darkening fade around the edges and corners of objects. And then it also creates a little bit more elaborate light bouncing contribution from the Final Gather that we turned on. So, so yeah, in general, this is kind of an intro to how lighting works in a system like this. And one thing that I think is important to note on why you might want to bake lighting is that you can potentially get higher quality, higher resolution lighting for lower cost by using baked GI. So if you can set this to a substantially higher texels per world unit than you would be able to using the pre-computed GI. And so just to help you visualize how this stuff works, under you see where it says shaded here in the scene view, you can actually change this to view some information about the global illumination process. So for example, if I go to UV charts, this gives you a rough idea of how many pixels are being used for light bouncing contribution. And then you can see, if you go through each of these categories, you can see different aspects of how the system works. So most of these are for the dynamic global illumination, but you'll notice that if I look at the UV charts, this is actually showing what the pixel resolution is for our current pre-computed GI. And then if I go down here to baked, this shows how many pixels we have for the baked lighting. And you'll notice that it's substantially more than what you would normally have if you were just doing the pre-computed real time. So, okay, I think that's a pretty good introduction to how this works. Hopefully this makes sense to you guys. One last thing I wanted to show you is when you're doing pre-computed lighting and you're not actually doing the pre-computed real time and you're doing actually the fully baked light, if I create a spotlight, like for example, and I turn on shadows, I change it to a baked light, and I extended the spotlight angle, and I place this in a spot, maybe like that, and then I increase the intensity a bit. When I bake this, it's actually going to bake the light entirely and all the lighting contribution. So if I go ahead, I'm going to turn off the ambient occlusion, and I'm just going to bake this again really quick. Now, the one thing that you've got to keep in mind with baked lighting specifically, and this is true in all of the lighting scenarios, but it's particularly true in baked light, is that you really have to have reflection probes when you're baking the light in an environment like this, because objects that are not baked will not be able to receive proper lighting contributions at all from the scene unless you have light probes. So just bear that in mind. So for example, like in my light probe group here, I'm actually going to pull this light probe up because it looks like it's not getting calculated properly. But so if I turned off my light probe group for a second, so if I disable that completely, this object cannot receive lighting even from the object here. So but if I turn on my light probes, I can actually add additional probes to sample more of the lighting where this object is being lit. And so I can add a couple more here. And then I want to make sure that I've got everything is baking properly. So right now it's not receiving any contributions for that lighting, but once we bake everything together, then we should see those light probes actually sampling from the baked lighting. And so you'll see that like the light probes here, like so for example, this is a light probe that is inside this shaded area, but this is a light probe that is directly on top of where this was being hit by a light directly. So for example, when the object is all the way over here, it's going to be kind of in shadow, and when it is up here in the main environment, it has a brighter lighting contribution. And if you want to have an idea of how the light probes are affecting something, you can see what the current contribution is by looking at that that probe that you see in the middle when it's being selected. So for example, if I changed this, it's probably easier to see here if I change the metallic and albedo properties. So for example, this is what it looks like when it's in the light, and this is what it looks like when it's in shadow. And it has kind of like a rapid natural transition between those states. And then if you bring it down into the shadow here, the only thing that you need to keep in mind with this is that it doesn't actually do direct shadowing anymore. It just does the light probe contribution. So you've got to be a little bit careful with how you use this, because if you need shadows on an object, this may not be the way to tackle it. So just be aware of that. And that's, I'm going to go ahead and wrap up this lesson, because actually I think it went closer to the full length of time than I expected. So I'm going to go ahead and wrap this up. Thanks for watching. And I hope this gives you an idea of how lighting works in Unity 5.